Today I will talk about stochastic models of inventory management. This is part of my series of lectures on operations management. This is the diagram I have taken from recent article, and this is the diagram I have taken from the classic article by Disney SM et al. In the year 2005. So in the recent article, this figure, there is a market demand and there is a forecast of the market demand. And in response to this market demand, a quantity is delivered to the market, that is DQ. And this DQ is out of the initial inventory. And after meeting the demand, the leftover inventory is known as terminal inventory. There is an arrival quantity in response to our orders. And this arrival quantity add up to the inventory. That is it adds to the initial inventory. And the inventory in transit is known as work in process inventory. So in response to the forecast of market demand and work in process inventory and the inventory level, we order a particular quantity. So this is how the stochastic model of inventory management works. So let us see this. In the classic article by Disney SM et al. In the year 2005, there is the grouping of these related stochastic inventory management models. And this is the diagram illustrating these various models. And in the recent article, which I mentioned in my previous slide, the model used is API OBPCS, that is automated pipeline. And in that article, a simulation was done to validate this model. So let us see in detail various quantities. So this is the delivered quantity, that is quantity delivered to meet the market demand D. So it is the minimum of either the market demand or the initial inventory. So this is the minimum of these things. If the initial inventory is less than market demand, there is shortage. So this is the terminal inventory of a previous period. So if we add to the terminal inventory of previous period, arrival of the current period, we get the initial inventory of the current period. And the terminal inventory of the current period is maximum of either 0 or the difference between the initial inventory and the quantity delivered for meeting the market demand. If there is shortage, then the market demand is more than our inventory. And this shortage quantity is maximum of this, either 0 or this difference. And the service level at the point T is defined as 1 minus shortage quantity divided by the market demand. So this is work in process inventory is equal to work in process inventory of previous period plus quantity ordered. So this is the ordered quantity minus which have already arrived. So this is work in process quantity which have not still arrived. Now the forecast, this is the exponential weighted moving average forecast. So this depend on this factor theta. And this is the ordered quantity. So ordered quantity is the maximum of either zero or this term. So let us see what is this term. This term have three components. One is forecast, the other is inventory level, and the third is work in process inventory. So this I have already described the delivered quantity, initial inventory, terminal inventory, shortage quantity, work in process, and forecast of market demand. So this ordered quantity, this is our actually decision variable. So this ordered quantity is equal to maximum of either zero or this. And these three terms are the function of sales forecast, that is this, inventory deficit, that is this term, and pipeline deficit, that is this term. And these parameters, alpha S and alpha SL, may vary between 0 and 2. And this parameter is 0 for ideal state of zero inventory. And service level, as I have described before, is defined as 1 minus shortage quantity divided by market demand. So this is all about stochastic model. Thank you very much.